Example 3, this is one where everything's in explicit notation. Things aren't in function notation. What we have here is, I'm going to rewrite this equation with the 2 on the other side. And I also notice, so I'm going to put the plus 2 on the other side. Do you notice that inside the square root, there is a horizontal compression, because that 3 means multiply by a third. There's also a horizontal translation, because you're adding and subtracting something. But notice in this one that it isn't in factored form. So we have to take an extra step and factor the 3 out so that it is in factored form. And when we label things here, this is outside, it's going to be a vertical reflection. This 3 is inside, it's going to be horizontal. You would multiply by 1/3, so it would be a horizontal compression. Here we have our horizontal translation, and it will be 1 to the left, not 3 to the left like we originally saw. And this is outside, it will become a vertical translation. We know that one point that we're going to do is 0, 0, because that's our starting point. So when I set things up here, I'm going to take 0, 0, going from left to right. I'm going to multiply y by a -1, x by a third. I'm going to move 1 to the left and 2 up. Now 0, 0 is the most important point on the square root graph because that's where it starts. So you will always have that point. Now on your square root graph, you know that you have, and this scale is a little bit crazy, but you have 1, 1, you have 4, 1, 1's not quite in the right spot. You have 1, 1, you've got 4, 2. Those are normally the points that we started with. They've given us this scale because they really want us to see this point on here, 9, 3. Why is 9, 3 a better choice as a second point other than 1, 1 or 4, 2? Yeah, it's divisible by 3, so we can avoid some of our fractions. If you can see that early, you're going to save yourself some time and make your life easier. If you don't see that and choose to use 1, 1 and 4, 2, it's not wrong. It'll just mean you have fractions to work with, and that's not bad either. It just might take a little bit more time. So if I choose to use 9, 3, I think that my life is going to be a little bit more simplified because of that. 0, 0. When you multiply 0 by anything, it's going to stay 0, 0. And then you're going to move 1 to the left and 2 up. 9, 3. Y by a -1, that's going to change your y coordinate to -3. 9 by a third is going to change that to 3. Then we're going to go 1 to the left, 2 up, and those are our points. This one I'm going to graph on the same graph because it's not too busy. So what's going to happen, we're going to get -1, 2. Got to be careful with the scales because they're going by 2's here on the x-axis. There's -1, 2. And 2, -1. This is our starting point that connects with that one. The last part that we have to do is we know we're starting here, it's going through here. We have to make sure that we get our curve right. And when we're thinking about how it's been curved, run through these green transformations in your head, just roughly. Reflect it vertically. Now it's pointed down. Can you see that If you reflected it vertically, to start off with, it would look like that as a shape. Horizontal compression, it probably changed to be like that. Horizontal translation moved over to be like that. Vertical translation matches up perfectly with what we have in the end. So you sort of imagine those things to say, can I see that my final shape needs to look like this? What's the domain and range of this blue graph? I'll use interval notation since we haven't done that for a while. Our smallest value is -1, and it continues forever, so our domain would go from -1 to infinity. Our range, it has no smallest value, so it starts at -infinity, and the range of the y values continue up until they get to 2. 2 would be included, so we use a square bracket. And there's our domain and range. Okay, questions for practice on this one are 8 and 10.